Now that you've had an opportunity to do an inquiry task based on some of the laws of exponents and discover some of those rules on your own, we're going to go over them and make sure that you have them all correct. So the first one is the product rule. This says that when you multiply two exponents, whoa, how many times do I do that? Sorry. When you multiply two exponents with the same base, you keep the base and add the powers. So let's look at why this works. So a to the fourth power times a to the third power. So a to the fourth power, we should know is a times a times a times a, four of those a's, right there, times a times a times a. There's your three a's, okay? So now we would make that equal to, we would count off how many a's there are, 1, 2, 3, 4, 5, 6, 7. We know that's equal to a to the seventh power. And look at that, if we actually did a to the 4 plus 3 power, we would get that a to the seventh. So, as you can see, this is why these steps actually work. The next one we have is the power rule. Power to a power. That's how I like to say it. It kind of sounds like we're super people, superheroes. But regardless, it says when you're raising a power to a power, you multiply the exponents. So in the prior one, we were adding exponents. This one, we're multiplying exponents. Well, why does this work? So we're going to take a look. If, say, we had a to the third power, we wanted to raise that to the second power. So the power of 2 tells us that what's in parentheses gets multiplied times itself. So that's a to the third power times a to the third power. Now we can go right to that product rule that we just learned, which would mean that it would be a to the 3 plus 3 power, which would be a to the sixth. But that still hasn't really proven it to us. Let's take a minute and think about a to the third power. What does that mean? A times a times a, there's the first one, multiplied by a times a times a. And you should hopefully see where this is going. That there's 1, 2, 3, 4, 5. Whoa, I went too fast. 1, 2, 3, 4, 5, 6 a's. So that's a to the sixth. Now we know if we took that, a to the 3 times 2, that in fact would give us the a to the sixth power. So it should be relatively easy here to see why this rule, this law exists. So that's 2 of the laws. Moving along, the quotient rule. The quotient rule. So remember that fraction bar is division. Now that we're in 7th grade, that's how we always write that. So let's take a look at this. Suppose we had a to the 6th power divided by a to the 4th power. Let's take a look at that. So a to the 6th power would be a times a times a times a times a. 1, 2, 3, 4, 5. One more makes 6 divided by a to the 4. So I've got a times a times a times a. Now I should know, as you know, if you have the same value on the top as you do on the bottom of a fraction, or when you divide, if you divide the number by itself, they cancel. So those a's are going to cancel. Those are going to cancel. Those will cancel. Those will cancel. I'm left with a times a, which is a to the second power. And if I'd done what that step said, a to the 6 minus 4, 6 minus 4, of course, is a to the second power. So this shows how this works. Now let's take a look at another one. Let's take a look at, say, we had a to the second power divided by a to the fifth power. That's going to look a little bit different. A to the second is a times a divided by a times a times a times a times a, 5 a's. I take that same step, I cancel them, and I'm left with just these 3 a's on the bottom. What's going to happen there? So there's my division bar, or the fraction bar, it remains. I've got a to the third power on the bottom. What do I have up here? I've got nothing left. I need a placeholder. It's not 0, because of course that would mean it was 0. It's 1. Let's look at that step here. This says, if I follow the direction, it says a to the second divided by a to the fifth, be a to the 2 minus 5. 2 minus 5, well, that's negative 3. How are those the same? Let's keep that in mind as we're moving forward. I know I haven't quite proven that to you, but like I said, keep it in mind how we got from here, how we showed it and got to here, but when we did that operation, we got that negative exponent. Well, we're keeping that negative exponent in mind and know that it's coming. The 0 exponent. And a to the 0 power equals 1. Anything raised to the 0 power is always equal to 1, but why? Okay, let's take a look at this. Suppose we had, let's do a to the 4th divided by a to the 4th. And this is how we prove that 0 power. Now if we use the rule we just learned, that would be a to the 4 minus 4. Well, 4 minus 4 is 0. A to the 0 power, I don't really understand that. That seems weird. But look at this. What happens when you have the same value on the top as you do on the bottom? Well, it always equals 1. That's an interesting way to think about it. Let's prove it yet another way. Let's do this, write this out. A times A times A times A. And I think that's 4 of them. 4 down the bottom. Cancel them. 1, 2, 3, 4. I've canceled all of them. Does that mean everything's gone? Of course not. Again, I have that placeholder. There's really a 1 here. And 1 over 1, well, that equals 1. So in 2 different ways, you should have seen how a to the 0 power equals 1. Next, I'm sure you know what's coming is that negative power. A to the negative n is equal to 1 over a to the n power. We really already proved this when we were doing that subtraction earlier. Let's look at this again, make sure that we really get it, because this is, I know, somewhere where people tend to get stumped. So let's take a look at this. Let's pretend we had a to the, let's do a to the 4th power, that is an a, divided by a to the 5th power. If I write that out, it's a times a times a times a, divided by a times a times a times a times a. I do some canceling. Look at this a on the bottom. You just have an egg hanging around by itself on the bottom. Keep in mind anything times 1 is still itself. So this is equal to 1 over a. Let's see an exponent there. What does that mean? Well, let's look at our rule, a to the 4 minus 5. Well, if I take away 5 from 4, I do get negative 1, a to the negative 1 power. So that, in fact, does show me how these two are equal to each other. Now we got one more thing which you really don't have to know right now, but I like to show it to you. Make sure you really understand it. A quotient with a negative exponent. Oh, this is crazy talk, Mrs. DeSilva. Negative exponent. Negative exponents signify or mean division. In other words, whenever we divide, we're really finding the reciprocal of that base. So just like we did before, when we had, say, a to the negative 2, that was equal to 1 over a to the second. In a similar manner, if I've got 1 over a to the negative 2 down here, that then moves up to the top. So it would be a to the second power over 1. Of course, I ignore that 1. It would be a to the second power. And there's all your laws of exponents.